Today's lesson is over percent change and percent error. Percent change and percent error are really important real-life applications. Percent change is defined as the percent that a quantity changes for the original amount. So that's the formal definition here. We have two types of change. We have percent of increase. That's the amount that goes up. A real-life example of this would be a markup. Percent decrease is how much something goes down. A real-life example would be sales and discounts. Percent error is something that's a little different. Percent error is when you guess that something's going to happen and something actually happens. Then the percent error would be the percent that an estimated quantity or your guess differs from the actual amount. The way that we're going to find and calculate all of our percent change questions will be to find the amount of change, which we do that by subtracting. So we're going to do some subtraction. We're going to do some division. So we're going to subtract our new from our original, and then we're going to divide it by the original amount. When we get that, we get a decimal, and we're going to change it to a percent by moving the decimal 2 places to the right. Now in example 1, it's asking us to find the percent increase. And in this problem, the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? Well, before we begin, let's kind of think about what our original is and what our new is. In this case, Saturday comes before Sunday, so Saturday would be our original amount, and Sunday is our new. Remember, to find the percent change, we find out the amount of change, so change over original. We're going to be subtracting our new and original to find that change. Started off at 2, and then we ended up with 4.5 hours online. I'm just going to set up the subtraction problem, so we're subtracting our newest or our largest number. It will be in the problem first. This will be the smaller number from the larger number. And then we're going to divide this amount by the original. So 4.5 minus 2 gives me 2.5 divided by 2. And if we calculate that, if we put it in our calculator, 2.5 over 2 will give me a decimal of 1 and 25 hundredths. Now remember, this is supposed to be calculating a percent of change. So instead of answering as 1 and 25 hundredths, we're going to move that decimal 2 places to the right and tack on that percent sign. So the correct answer would be that there was 125% change from the amount of time we spent online between Saturday and Sunday. And if you think about it, 100% increase would be doubling where we started. So Saturday we spent 2 hours, doubling that would be 4. But since we spent 4.5 hours online Sunday, it makes sense that our percent change would be 125%, or a little bit more than doubling. So 125%, and this will be an increase because we started off with a smaller number and we grew, we increased. So it's 125% increase in the amount of time we spent online between Saturday and Sunday. Example 2 is asking us to find a percent decrease. The bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? Let's look at our bar graph. And in 2012, there were 28 home runs. And in 2013, there were 20. From our original amount to our new amount, we did decrease by 8 home runs. That's why it will be a percent decrease this time. We need to figure out what's our original amount and what's our new amount. We started off in 2012, so 2012 will be our original. New will be the 2013. Remember, we always do change over original, and we find the change by subtracting our two numbers. This time we're going to take 28 minus 20 to find the difference, and then always divide it by the original, which this time would be 28. 28 minus 20 is a difference of 8 home runs. The original would be 28. If we think about and enter in our calculator what 8 divided by 28 is, we would get a decimal of 286 thousandths approximately. Or if we change it to a decimal, that would be 28.6%. And since we started off in 2012 with more home runs than we ended up in 2013, this is a 28.6% decrease in the number of home runs this softball player hit between those 2 years. Example 3 is asking us to find a percent error. So percent error means there was just a little bit of a mistake made in our guesstimation. So here in this example, we're estimating that the length of our classroom is 16 feet, but the actual is 21 feet. We need to find the percent error. The percent error equation would be amount of your error. So again, with the amount of the error, we're subtracting, and we're going to put it over the actual. So instead of change over original, this is error over actual, or change over actual. We're going to put this as our estimate, and the 21 feet is the actual. We're going to find the change between those two by subtracting 21 and 16. Once we subtract, we're going to take that and divide it by the actual amount, which was 21. 21 minus 16 is 5, and then we do 5 over 21. If we type that in our calculator, means that we'll get a decimal of 238 thousandths approximately. Move that decimal over 2 places, and we were off on our guesstimation by 23 8/10%. Not too shabby of a guess, but it was a 23.8% error in our guesstimation. All right, that does it for the percent change section. Remember, if you can subtract and divide and move that decimal over 2 places, then you can find the percent increase, decrease, and error.